Today, we're embarking on a quick yet fascinating journey to extract tables from PDFs. Yes, you heard right, we're making it incredibly simple. We're calling upon none other than Google's Document AI service, a gem from Google Cloud. This fantastic tool gives us with built-in processors, saving us from having to write complex code to pull out our PDF tables. We'll be honing our abilities in a multitude of image and PDF extraction tasks. The beauty of it all, low code or no code at all. We'll showcase this simplicity both from the console and through simple Python code. Let's dive in. Create a new document and voila, you can siphon out tabular data. We'll speedily demonstrate this in code, but feel free to just upload test documents right here. Let's upload a handy example from Google Cloud's Documentation Hub. We've fetched headers here and multiple rows perfectly captured within this table. You can visually interact with this form or get at the extracted results. For example, you can export the JSON to get the results in a format easy for other data processing and analysis. Still, manually extracting tables for every PDF could turn into a Herculean task, particularly if you're dealing with numerous files. No worries, we'll show you how to efficiently work through this with Python via a Jupyter environment on Vertex AI Workbench. There's no need to plunge into complexity for this Jupyter environment. Let's just use the default option, which will cost you 20 cents hourly. Yes, you can modify your setup to adjust the costs, but for this demo, we're merely using it for about an hour. Once we've spun up our Jupyter environment, we can draft out our PDF parsing code, essentially replicating the console process, but in a more scalable fashion. Get ready to start up a Python environment. Let's bring in that same PDF form we used that had the table. First things first, let's handle our much-needed imports. The Google Cloud Document AI library is imperative, and let's rope in pandas as well to crunch the data once we get the raw parsing results. Seems like we're missing our packages. No problem. Pandas is already available in this environment, but Google Cloud Document AI may be elusive. Let's summon it in with a quick pip command. Success. Now let's pivot towards setting our variables. The Document AI client needs a location pointer. Let's define this as a constant. Remember our form parser? That needs a project ID and a processor ID, effortlessly snagged from the Document AI page. Additionally, we must specify our file storage location and type. For us, it's application PDF, but it could be a perky PNG or a jazzy JPEG. We've spun our client into existence, and up next is our processor as a Python object. Now that we've navigated past the boilerplate client code, bring on the thrills, processing the file. We'll bring the file into memory before performing the minimal yet impactful processing. The process will birth a raw document variable via a Document AI endpoint. All right, so it took just a few seconds, but we've got that result, which we can use in some subsequent analysis. So let's save the document portion of that result and then get started on some processing. We're going to store our header and body rows in some lists here, and those actually will be lists within lists, but we'll compile that as we loop through the pages in the document object. We have this looping here just because we could potentially have multiple tables on a page or across pages. Now we have to employ a couple of helper functions here once we start to compile the header row values and the body row values, and that's because of the way that these are stored. So the first thing is we want to create a function for getting the table data. That's just going to take our rows and we're going to loop over these. So this is just going to loop over our rows here and then the cells in those rows. This is pretty basic, but we do need a way to basically convert the offsets of, our table data into a string, so we're going to need one more function here. We'll grab that function and save it, get the table rows function as well, and then we should be in pretty good shape to do some additional processing. We'll just finish up by creating a Python pandas data frame using that rows data and within the column values indicated by the header rows array. All right, so that might be enough. Let's see if we can run this. So just fixing a couple of typos here quickly, and that seemed to do the trick. So after those quick typos, we can click on our output here and get the same result as before. Again, keeping in mind that this is now an automated process that we can run in batch and potentially process hundreds of different PDFs. With that, we'd like to thank you very much for joining us on this exciting voyage. If you have any questions or encounter any challenges, don't hesitate to reach out in the comments. Please enjoy it responsibly.